Hi students, today I am going to explain an example problem. This problem is based on chapter 2. Let's first read the problem here. A manufacturer uses 4-stage manufacturing process to convert aluminum castings of engine cylinder blocks into finished engine cylinder blocks. The weekly demand is 2000 units. The scrap rates are given. Scrap rates means defective rates for each machine. So if we understand it correctly, what's happening is the manufacturer is getting castings for castings of engine cylinder blocks, right? And then he is using a 4-stage manufacturing process, maybe 4 different machines, we can assume 4 different machines, right? To convert those raw castings into finished parts, finished engine cylinder blocks, right? The weekly demand is given as 2000 units, okay? And let's see here, let's look at this figure here. This is a block diagram that shows the manufacturing process, right? So there are 4-stage, 1, 2, 3, 4-stage manufacturing process. The finished part comes out here, right? After the raw casting goes in the first machine, then from there to second, third, fourth, and finally we get the finished output here, right? Each machine has some scrap rate. That means they cannot make 100% good parts. There is going to be some defect, some manufacturing defect associated with each machine, and some parts we will have to eventually scrap, right? And remember, according to the problem statement, the demand is 2000 per week. That means every week here at this output, final output, we need 2000 parts every week. So in machine 4 here, if we look at it, the defect rate is given as 3%, right? Sorry, this is machine 4. Machine 4 defect rate is given as 3%, machine 3 5%, machine 2 5%, and machine 1 8%. D1, D2, D3, D4. Now the question asks, how many parts, how many castings do we need every week here? How many castings we need to input into the process so that we can get 2000 parts out here? And remember, the machine cannot each machine is producing some scrap. Each machine is making some parts bad, right? So we need to throw those parts. So okay, then we can look at the solution. I already have a solution here. So let's say when we do calculations, what we get is sometimes we get decimal values, but what we will do is we will round them to the nearest integer, because it doesn't make sense to say 4.5 engine blocks. There won't be any 4.5. Either there will be 4 engine blocks or 5 engine blocks, right? There will not be any decimal quantities. It should be integers. So we will round whatever calculations we do, we will eventually round them to the nearest integer. Okay, so let's take a look at the at the 4th machine here. So we need 2000 parts out of the 4th machine. So how much should we put? How much input should we put at this stage? How much input should we feed to number 4 machine? So we do that calculation. So I'm gonna call that input for I4, right? I sub 4, which is equal to 2000. 2000 is the parts that we want out, right? Divided by 0.97. Now some of you will ask where this number came from, 0.97. So again, going back to machine 4, if 3% is the defect rate, that means 97% is a good rate. Good rate meaning if we put 100 parts, 97 will be good parts come out of the machine, and 3 parts we will have to throw away, right? So those 97 parts, that means 3% and 97%. 97% means 0.97, right? 0.97. So we divide the output quantity that we want divided by the good rate, 0.97. So if we do that calculation, you get 2062 units. So that's the number of units that needs to go into the machine 4 to be able to get 2000 good units out. and 62 will be scrapped as per the 3% scrap rate, right? So that's for machine 4, but we need to find out what the number here, how many castings we need at the beginning stage. So then on the next line you will see that I have I3, that means now we are here, right? How many parts we need here, and obviously as we go back into the chain, the numbers we're gonna need more and more and more numbers, right? So if we needed 2062 units here, we will need more than that here because there is a 5% scrap. So again we want 2000 at the output, so I put 2000 there, divided by now we need to consider two machines, so 0.97 for the first machine multiplied by 95% good rate, 95% good rate, so 0.95. So we need to divide 2000 by 0.97 by 0.95, right? So we need to divide by these two numbers, and we get the answer we get is 2171 units. So we need 2171 units at this stage here to be able to get 2000 out here, right? Similarly, then we go back and we find out the input at the second stage. So we divide 2000 by, again, 5% scrap rate, that means 95% good. So we divide by 0.95 for these, 0.95 for these, and 0.97 good rate for 4. So we divide by these 3 good rates for 3 machines, right? Then we get 2285 units at second. That's those many numbers we need here to be able to get 2000 out here, right? Then final answer is actually that's one we want, is we need number of units here. So that's where I1 is equal to 2000 divided by 0.97 for machine 4, 0.95 for machine 3, 0.95 for machine 2, and first machine is it has a highest scrap rate, 8%. That means only 92% parts can be good. So we divide by 0.92. So all in all, if we do that, you get the answer 2484 units. So we need the manufacturer will need 2484 castings every week to be able to produce 2000 finished products, to be able to deliver 2000 unit finished products, right? And the 484 parts will be scrapped in different machines, right? So that's basically it for today.